Chronic inflammation. A meditative journey through the body. Close your eyes. Take a slow, gentle breath in and breathe out. Let your body become still. Now imagine that you are becoming incredibly tiny, smaller than a cell. You enter the human body and you arrive inside a small piece of tissue. Everything is peaceful. Blood is flowing gently through the vessels. Cells are living quietly. Everything is in balance. Until suddenly, injury. Something has gone wrong. Maybe a persistent microbe has entered. Maybe a toxic substance is continuously present. Maybe the immune system itself has become overactive. At first, the body launches acute inflammation. Blood vessels dilate. Vascular permeability increases. Neutrophils rush into the tissue. The battlefield becomes crowded. You watch the neutrophils fight, but the offending stimulus is difficult to eliminate. The battle continues. Days pass, then weeks, and now something changes. The neutrophils are no longer the main characters. A different cell begins to dominate, the macrophage. You see a monocyte leave the blood vessel, enter the tissue, and transform into a macrophage. Another arrives, and another, and another. The tissue slowly fills with macrophages. This is becoming chronic inflammation. Take a breath. Look closely at one macrophage. It is not simply a killer. It is both a destroyer and a healer. It swallows microbes. It removes dead tissue. But then, it releases inflammatory mediators, tumor necrosis factor, interleukin-1, chemokines. The inflammation continues, and the macrophage itself can contribute to tissue injury. You see the tissue becoming damaged. But at the same time, the macrophage begins calling the repair team. Growth factors appear, fibroblasts arrive, new blood vessels begin forming, collagen begins accumulating. So inside the same tissue, injury and repair are happening simultaneously. Inflammation, tissue destruction, and repair, all together. This is the heart of chronic inflammation. Now watch the macrophage, standing at a crossroads. On one side is the M1 pathway, the classical pathway. Microbial products appear. Toll-like receptors are activated. Interferon gamma arrives. The macrophage becomes an M1 macrophage. It becomes a warrior. Reactive oxygen species, nitric oxide, lysosomal enzymes. It attacks microbes. It promotes inflammation. Remember, M1 means military. M1 means microbe killing. Now turn toward the other path, the M2 pathway, the alternative pathway. Interleukin-4 arrives. Interleukin-13 arrives. The macrophage changes. Now it becomes a repair worker. It produces growth factors. It produces transforming growth factor beta. It promotes wound repair. It promotes fibrosis. It helps terminate inflammation. Remember, M2 means maintenance. M2 means repair. And notice, the tissue does not always contain only one type. Different macrophage states may exist together. The battlefield is complex. Now, look around. Another cell is arriving. A T lymphocyte. The macrophage presents antigen to the T cell. The T cell becomes activated. And now, the T cell sends signals back to the macrophage. The macrophage sends signals back to the T cell. Back and forth, back and forth. Macrophage to T cell. T cell to macrophage. Macrophage to T cell. T cell to macrophage. A continuous cycle. The inflammation feeds itself. This is why chronic inflammation can become persistent and severe. Now 3 T cells step forward. The first is Th1. Th1 releases interferon gamma. Interferon gamma activates macrophages through the classical pathway. Th1, interferon gamma, M1 macrophage, inflammation and microbial killing. Now the second is Th2. Th2 releases interleukin 4, interleukin 5, and interleukin 13. Interleukin 5 recruits eosinophils. Interleukin 4 and interleukin 13 promote alternative macrophage activation. Think Th2, allergy, helminths, eosinophils, and M2, macrophages. Now the third is Th17. Th17 releases interleukin 17. Interleukin 17 promotes recruitment of neutrophils and monocytes. So even though neutrophils are characteristic of acute inflammation, neutrophils can still persist in some forms of chronic inflammation. Now imagine a parasite entering the tissue. Eosinophils arrive. Their granules contain major basic protein. They attack the helminth, but their weapons are powerful, so powerful that they can also injure the body's own epithelium. The same weapon that protects can also damage. Nearby sits a mast cell. Its surface carries Fc's epsilon, RR, I receptors for IgE. An allergen appears. IgE recognizes it. The mast cell suddenly degranulates. Histamine, prostaglandins, cytokines, and inflammation intensifies. Mast cells can participate in both acute and chronic inflammation. Now, the most beautiful image begins. The offending organism is still there. The macrophages cannot eliminate it. So the body changes its strategy. It says, Meizib, if I cannot destroy you, I will surround you. One macrophage moves forward. Another joins. Another. Soon they form a tight collection. Their cytoplasm becomes abundant. They begin to resemble epithelial cells. They are now called epithelioid cells. Around them, you see lymphocytes. Outside them, you may see fibroblasts and connective tissue, and some macrophages fused together. One cell, many nuclei, a multinucleated giant cell. The granuloma is forming, a cellular prison. Now walk into a tuberculous granuloma. You enter the center. It looks pale, granular, cheesy. This is caseating necrosis. Around the necrosis, epithelioid macrophages, giant cells, lymphocytes, and fibroblasts. Remember, tuberculosis is the prototype of granulomatous inflammation. The granuloma is trying to contain something that refuses to be eradicated. Now change the scene. Imagine a granuloma in sarcoidosis. There is no cheesy necrotic center. It is a non-casseting granuloma. Now imagine Crohn's disease. Again, usually non-casseting granulomas. Then imagine a foreign body, a suture. The macrophages cannot engulf it. They gather around it. They form epithelioid cells and giant cells. This is a foreign body, granuloma. Now step backward. Look at the whole tissue. You see macrophages, fighting and repairing. You see lymphocytes, sustaining the response. You see plasma cells, producing antibodies. You see eosinophils, especially in parasitic and allergic reactions. You see mast cells, releasing inflammatory mediators. And sometimes you see neutrophils, continuing to persist because the offending stimulus remains. You see injured cells. You see destroyed tissue. You see new blood vessels. You see fibroblasts. You see collagen. And suddenly, you understand chronic inflammation. It is not simply inflammation that lasts a long time. It is a battlefield that never completely closes. The offending stimulus remains. The immune cells remain. Tissue is continuously injured, and simultaneously, the body continuously tries to repair itself. Inflammation, tissue injury, repair, all existing together. Take one slow breath in, and slowly breathe out. Now let the entire picture settle into your mind. When you hear the words, chronic inflammation, see persistent stimulus, see macrophages, see tumor necrosis factor, see interleukin 1, see chemokines, see lymphocytes, see the macrophage and T cell talking to each other, see persistent inflammation, See tissue destruction, see angiogenesis, see fibrosis, and if the offending agent is difficult to eradicate, see the granuloma forming, epithelioid macrophages, giant cells, lymphocytes, fibroblasts, and in tuberculosis, see the central caseating necrosis. Let the entire 6 pages become one single mental movie. Persistent stimulus, macrophages, lymphocytes, tissue injury, repair, fibrosis, and sometimes granuloma. Take one final slow breath and let the knowledge rest quietly inside you.